Hello, my name is Amit Patel, and I am going to discuss my research project on a fuzzy logic-based expert system for stock evaluation. The motivation behind this project was really to try and introduce fuzzy logic rules to kind of simplify in linguistic terms the different kind of metrics that you see in the stock market. And I'll get into more detail as the slides go on, but just to leave you guys with something to think about. Currently, there's a lot of metrics like price to expense ratio or return on equity, which are percentages that fluctuate severely based on the company and based on the market that they're trying to capture. And what if there's a way using fuzzy logic to get rid of looking at these numbers and instead have rules underlying which tell you whether you have a good decision to invest or a bad decision to invest. And that was the goal behind this paper. So, getting a bit deeper into the slides and what this paper was about, we really have traditional methods currently in the financial system to decide if we want to make the investment. For example, stocks such as Facebook or Google that lead the S&P are severely tied to, PDE ratios. And most traditional systems have a binary logic tied to those PDE ratios. If, for example, I have a PDE ratio that's 15.01, I know that my price is a bit higher than what my earnings are. And if I have a binary detector set at 15.00, I would not hit this threshold and I would not buy this stock. Now, let's say this happened when Google was trading at 190 a share. I don't know if you guys follow the stock market, but right now Google's trading at over 300. That PDE ratio would have cost you a 40 to 50% gain in the stock. And ultimately, I give this case study just to highlight that there's a trap with the binary approach. If you just look at the raw numbers, you'll get stuck and you won't make a more informed decision. You need to be able to capture what the raw number means in a particular market. For example, Google's PDE ratio, whatever it was, I'm not sure off the top of my head, was justified. They were going to capture a large share of the AI market, and they did. Um, so having a binary detector fails to highlight what market Google's going to capture. And the last point I want to leave you guys with is concepts like value and risk are objective. They're not consensus views. So your version of risk can be different from mine, but why not group together a bunch of financial metrics, such like PDE, such like return on equity, such like IRR, and come up with something that can encapsulate all of that so that we have a leveled framework of what risk means and what value means, and it'll help us make a more informed decision. Sorry. So I want to get into how we went about the fuzzy logic. Again, this isn't binary. This is more than just a zero and one, right? As you can see here, I have two membership functions. And basically what membership functions are for fuzzy logic is they try to basically have a mathematical shape attached to a particular financial KPI, which you see on the x-axis, and it maps it to a particular linguistic term, like you see in the um, chart of undervalued, fair, or overvalued, right? That label. So what we're trying to do is we're trying to take a mathematical shape and bound where the KPI, financial KPI will land. And based off of that bounding, we will create a linguistic term with this particular decimal value ranging from 0 to 1. And ultimately, what you can see here is I have two charts, one for price to earning and one for my return on equity. And both of these functions bound where price to earnings is great and where return on equity is great. And similarly, when price to earnings is bad and when return on equity is bad. For example, for my input one, you want a very low price to earnings. You want to be able to find an undervalued stock because you know that it's going to grow, which is that blue top curve. Then similarly, we know a range for what's fair valued and what's overvalued. Now, going to input two, we have the same curve, but instead now it's flipped. You want the highest return on equity. So the right side has an excellent term, and accordingly, the left side of my plot has a low return on equity, which means that it's poor investment. Now, what happens with these two curves is I take both of them in as inputs to my functions. One is price to earnings and one's return on equity. And I basically have an inference engine. I have a set of rules, which are 9 rules, and two are listed below. And this is based off the Mamdani inference, which I don't really want to get into because I really want to focus on what this project is geared towards as a real world application. But if my PDE is undervalued and my return on equity is high, then I know my valuation is excellent and I want to make this trade. And these rules will be defined similarly. Now, if I know my PDE is overvalued and I know my return on equity is low, then I know my valuation is poor and I don't want to make that investment. So, based off of these rules, and based off the Mamdani inference, which does a bit of min and maxing of the two membership values that you see on the y-axis here, I'm able to generate this curve. And I know this looks pretty daunting, but actually it's super straightforward. What we're doing here is we're creating a 3D structure of the PDE versus return on equity curve. If you look, when I have a low PDE and I have a high return on equity, my valuation score is high. If I have a high valuation score, I know I want to make that investment. Similarly, if I have a high PDE but a low return on equity, I have a low valuation score and I won't make that investment. So what I was able to do is I can take KPIs like PDE and return on equity, and I'm able to generate a valuation score, a number that we want to have to make a more informed decision. Now, this valuation score can then be mapped to excellent investment, an okay investment, or a poor investment. And we simply look at the underlying valuation score as a means to determine if we should make the investment. And that is something that's beautiful. Instead of looking at binary 0 to 1 on the PDE or a binary 0 to 1 on the ROE, I combine both of these and I make a single score. And both these KPIs take into account certain functions of how the stock would behave in the market. Like Google's return on equity is probably very high, even though their price to earnings is high. So from that more informed decision, we have a simple rule. And now I want to talk about what the future is of this project. Like I really got into it with the Python, and I realized like there's a lot of things we can do here. We can take an NLP approach where you take PDE, you take ROE, but you also look at what people are saying on Twitter about the stock of interest. And you can tokenize their tweets and you can have an market sentiment score based off of um, NLP library in Python, and you can use that as a metric also for your rule-based system. And you can scale the rules to have a more informed um, investment decision. On the other hand, what if you had a genetic algorithm, right? what if my rules that I define, right? I've hard coded these rules, but what if a algorithm then updates the rules based off of my stock's returns? Let's say a high PDE and a high ROE also gets me a really good investment. It's overvalued, but there's a lot of return on equity, so I should make that investment. And a genetic algorithm could take care of that from all of the decisions that's made in the past. So this is just some a scope on what I've done. I hope you guys enjoy this, and I hope you guys have a great holiday.